Okay, we have finished with part 1 where we were discussing exponential growth, and that is used a lot when we're calculating population growth. And now we're going to look at a second exponential function known as exponential decay functions. And that is used when we're calculating, say we're sick in the hospital and they're giving us medicine, and in order to get well we have to keep a certain amount in our body at all time. So we'll know the percentage of decay, or the amount of medicine as it moves out of our body, so that we'll know how much and when to put it back in to keep the medicine at a certain rate. They use that for chemotherapy. So anytime that you're putting caffeine, how long's caffeine going to last? So you know how soon you need to quit drinking any caffeinated beverages before you go to bed. So now we're going to look at the decay functions. They are also continuous, one-to-one. However, these are different that they're decreasing. Notice the domain is still all real numbers, and the range is positive real numbers. It has an asymptote also at x-axis, and the intercept is at 0, 1. So let's look at graphing an exponential decay function, and we're going to graph the function y is equal to the 1/5 to the x. Again, we'll do a table of values, substituting values in for x to find out what y is, and then graph that function. The domain is still all real numbers, and on this graph the range is y, such that y is greater than 0. Now they're wanting us to graph the function y is equal to -4 times 1/2 to the x minus 1 plus 2. Now this equation represents the transformation of the graph y is equal to 1/2 to the x. That's the parent function. Let's look at the parameters of this one. Notice there's a negative sign in front of a. So that means that this graph is going to be reflected in the x-axis. A is 4, so that's greater than 1, so we know it's going to be stretched vertically. H is 1, so the graph is translated 1 unit to the right, and K is 2, so it's going to be translated 2 units up. So after plotting all those values, we graph in a smooth curve. The domain is all real numbers, and the range is y, such that y is less than 2. So let's try our hand at it. Graph the function y is equal to 1/2 to the x. Pause this for a moment, do your calculations, and then come back and check your answer. Excellent. We've got a parent function here. The answer is A. Good job. Notice this one's decreasing. It's positive. See, we have a positive A. Now graph this function. Y is equal to -6 times 1/3 to the x minus 2 minus 3. Pause this for a moment, do your calculations, and then come back and see if you got the correct answer. Excellent. The answer is A. Notice our A is negative, and it also is a 6, so it's going to be stretched vertically. And it's going to go 3 units down, so we're looking for those that are going down and have a negative slope. We have a real-world example. Here we're looking at air pressure, and so it's going to be very similar to the exponential growth factor, except we're looking at exponential decay. The only difference is in our function, y is equal to a times 1 minus r, where in our exponential growth we had 1 plus r. So we can just simply substitute the values in. 14.7 is our a. We're going to change 20% to a decimal. And notice 1 minus r, our rate is 20%. So 1 minus 20.020 is 80 hundredths. So 14.7 times 80 hundredths to the t. We graph the equation. So now they want us to estimate the atmospheric pressure at an altitude of 10 miles. So we're going to use the equation that we used in part A. And now we're given what t is. T is 10 miles. So we're going to replace t with 10. And we use a calculator and we get it's approximately equal to 1.58 pounds per square inch. The atmospheric pressure at an altitude of about 10 miles will be approximately 1.6 pounds per square inch. Let's check your progress. I will let you take a little minute to work this out and then pause this and come back and see that you got the correct answer. Good job. The answer is B. So you had 34.7 times 1 minus, and don't forget when you changed your 3%, move your decimal place over 2 places to the left, 0.03. So when we subtract, we have 0.97. We needed to get that answer right in order to calculate this one. So now we are going to use that other formula. And we're going to substitute in for 20 miles. Pause this, do your calculations, and come back and check your answer. Good job. The answer is 18.87 pounds per square inch. And that is it for this lesson. Now you're ready to begin your skills practice. Good luck and work hard.